Hey Carter and whoever's watching this for the 8th period class, because I don't know who's not here. This is section 610 for Algebra 2. And this is solving, in the last section we solved log problems. Now we have story problems to solve for. So if you've seen the homework assignment already, you know that it is like a lot of story problems. And we're going to be solving these, okay? So there are some equations that I'm going to want you to write down off to the side. Quit it. Off to the side of your paper, I'm going to have you, actually, should we put them all in the same spot? All your equations, okay? So let's just put them at the top of the paper. And as we add equations to what we can use, I'm going to have you put them at the top of the paper. So the first one that we're going to be dealing with is half-life. You guys know what half-life is? Half-life, okay? When you're talking about like radioactive decay or any type of decay, you have something that has a half-life. So like if a chemical element has a half-life of like 20 years, it takes 20 years before the amount of it splits in half, right? So let's say there was 100 grams of some sort of substance on the earth and it splits in half in 20 years, okay? That means 20, don't write this down. 20 years would go by and it would become 50 grams. And then 20 more years would go by and it would become 25 grams, and then it would split in half again after another 20 years and it would become 12.5 grams, and so on and so forth. It splits in half, okay? The equation for half-life is that, I'm just going to use the same variables A, they might use different ones down below, but A equals P, which is the starting amount, times 0.5, why 0.5? Because that's half, right? To the, let's say T over H power. What the heck? T over H power. Now, we know what A stands for. We know what P stands for. Let's write them in there. What's A? After amount, or the result. P is the principal or the starting amount. T is time. And what's H? H is whatever that substance half-life is, how long it takes to split in half. So this is the half-life of whatever substance they are giving us, and they have to tell us what their half-life is, okay? So that's what we are going to, that's the formula that we are going to use. We're going to add more formulas to this, so we'll just put them at the top of your paper so that you have them all to use, all right? The first one, exponential decay, the half-life of a radioactive substance, we're going to be using that same formula that we just wrote down, is the time it takes for half of the atoms of the substance to disintegrate, to cut in half, right? We are talking specifically about carbon-14, and it takes 5,730 years for it to split in half. You guys have carbon-14 in your body right now. And what happens is, like when things die, or like mammoths or dinosaurs or whatever, what they will do is when they recover those fossils, when they recover the bones, they will test it for carbon-14 and they will figure out how much of the substance is in it, and then they can use that to date it back to figure out how long ago that animal lived. Does that make sense? This is exactly how they do the dating of, species and stuff. They do carbon-14 dating, and this tells me how long ago it lived, okay? So determine the value of K and the equation for the carbon-14, okay? K, we did not call it K, we called it H, okay? So what is the value of H if I go to plug it into that equation? What is the half-life? 5,730 years, okay? And we are plugging that in and writing an equation for this thing, okay? So all we're going to do is plop stuff in. A equals P times 0.5 to the T over 5730, okay? And there's really not anything that we're solving for. Determine the value of H, that's 5730, and write the equation for this carbon-14 dating. So this would be the equation that we would use, and then they would say, if you have a substance that is 100 grams and it's been dead for 1,000 years, how much is it just left? And we just plug stuff in, okay? But for this problem, all they're asking for is the equation. Does that make sense? We're going to use it down below. Happy with that? All right, example 2, a paleontologist examining the bones of a prehistoric animal estimates that they contain 2% as much carbon-14 as they would have contained when the animal was alive, right? So, has it decayed a lot or not a lot? Now it contains only 2% of what it was before. It's been dead a long time, right? A long time. What percentage does it start with? It starts with 100%, right? It's got 100% in it. And now we're down to only 2%. When 100 splits in half, it is now 50%. When 50% splits in half, it's 25%. When 25 splits in half, it's 12.5%. When 12.5% splits in half, it's 6.25%. And then it keeps splitting and splitting and splitting until it gets down to 2%, right? So it's split in half quite a few times, right? Quite a few times. How long ago did the animal live? It's been dead for lots of years, right? Each time it splits in half, it takes 5,730 years to do that. That's a lot of 5730 years that it's splitting in half by, okay? So it says how long ago. We're going to use the equation to do this. We're not going to actually think about this at all. How long ago did the animal live? Part A says how long. How long is, we're solving for time. Time is what we don't know, okay? All right, so the formula, if you need to rewrite it down, is A equals P times 0.5 to the T over 5730. That's the formula that we just established from the thing above, okay? And we're solving for time, which means we have to know what P and A are. And they don't really specifically tell us what P and A are, but they tell me that what's left over is 2%. What's left over is 2%. So where does the 2% go? A, that's after, right? So what we can do is we can use the A to represent a percentage, but what would my first percentage be? 100, right? So it doesn't matter what those two numbers are. We have no idea how big this animal was to begin with. We don't know what P was to start with. But we do know that what's left over is 2%. So all we need to do is just make sure that this is in the relationship of 2%. What we're starting with, what we're ending with. So 2% and 100. 0.5 to the T over 5730. We have solved things like this before. And we're solving for T. We're trying to get that T down. Okay, what can you do first for this thing? No, we're not. We can't multiply the 100 and the 0.5. You can't do that because this one has an exponent on it. So you can't put those two together. Divide by 100. Let's do that. Let's move him over to the other side. We've done that before, right? We're going to divide by 100. What's 2 divided by 100? Move the decimal. If you get 2 questions out of 100 right, you got a 2%. 0.02 equals 0.5 to the T over 5730. Okay? Are we happy with what's going on now? Yeah? Okay, now I have that T up in the top, and there's only one way of him coming down. How can I make him come down? I have to use a log of some sort, right? So what we do is we can either put log in front of both sides or we can put ln in front of both sides. If this was an E, I would definitely want to put ln in front so that it canceled off, right? But it doesn't matter which one we use this time. So we could use log or we could use ln. It does not matter. Which one would you like to use?
Log.
Log, okay. So let's put an log in front and an log in front, right? Okay. All right, then that allows this guy to come down in front here. So let's rewrite what we've got going on here. I'm going to insert some parentheses. So 0.02 equals T over 5730 times log of 0.5. Okay, this is what we have going on. Whoop, I keep having weird stuff. All right, and then we have to decide how we're going to solve this thing. What would you like to do now? Divide by log 0.5. He says that is multiplied right here, so we want to do the opposite. We want to divide by log of 0.5. Log of 0.5. Okay, so we've got T over 5730. He's by himself over here. And we want to take log of 0.02 divided by log of 0.5. What does that decimal come out to be? I think that sounds better. 0.6 something. Did you close off your parentheses? It's 0.02 divided by 0.5.
I got 5.64.
5.64. We'll just go 5.64. Ah, that's what it is. 5.64. And this means that it's split in half 5.64 times, right? Didn't we kind of count over here? It's more than, it's probably a few times. Yeah, it's splitting in half a little bit over 5 times, right? Okay. So now, if each time it splits in half is 5730 and it's splitting in half 5.6 times, I multiply that 5730 over to figure out how long this thing has been dead. Just so take whatever decimal number you just got and take it times 5730. What'd you get? 0.3? Something like that?
32317.
Did you retype the number?
Yeah.
Yeah. Did you retype the number? Or did you just use 5.64, whatever it was before, and take it times? So he did not round it off at 6.4. He left the decimal number in his calculator and just took that times.
Oh.
So it will be a little bit more accurate on his. So 32,000 years that thing's been dead. Holy cow, that's a lot of time. Woo! But I thought the Earth was only 2,000 years old. Have you heard people say that? Happy 2022nd birthday to the Earth. Like, oh man, you missed something.
Like
Whatever.
No BCs.
Yep. The Earth was not created 2,022 years ago. Just FYI. Okay.
Try explaining it to someone.
I know. It's a struggle. Okay. Anyway, happy with that? Part B. If prior, that should be an R, research points to the animal being around 2,000 years old, how much carbon-14 should be in the animal? Oh, 20,000 years old, not 2,000. 20,000. I just said that wrong. How much carbon-14 should be in the animal? Okay, so now they're asking for the after amount. They're saying how much should it be if it's 20,000 years old, okay? But they still don't start me with a principle.
100.
Let's start with 100. Yep, we always use 100, okay? 0.5 to the, now we have a t, and our t is 20,000 divided by 5730, okay? Now, just before we do all this, and before we type it in, this animal had 2% of it left, and it's been dead for 32,000 years. How much is it going to have in it if it only is dead for 20,000 years instead? How much do you think? Just to take a stab. What do you think?
3 or 4 point something.
4, you mean like 4% maybe? I don't know. 2% is left after 32,000 years. It's only been dead for 20,000 years, so how much do you think is left? It hasn't split in half as many times, right? I'm going to say maybe like 5 or 10%. I don't know. We'll find out. Type this in to your calculator. 100 times 0.5 to the 20,000 divided by 5730. Try typing it in and see what you get. Oh.
We got 8.8 times.
0.5 to the. Okay, you have
Same,
to.
okay, we got the same number.
You got to insert
Because where's
your
one?
parentheses there.
8 point
and
something.
So you're gonna
parentheses
put
after that.
So, I go.
No, I inserted it.
I got
8.9 years, or 8.9 is the A.
what?
Yeah.
Did you get 8.9?
No.
No. You need to put parentheses around this stuff right here. And maybe you dropped a 0. Check it again. 8.9. What does that mean?
8.9%.
8.9% of the thing is left after 20,000 years, right? It still has 8.9% of whatever it was before in it after 20,000 years, right? You don't like this lesson. Okay. All right, good? Happy with that? All right, let's go to the next one. Let me see what we're talking about here. Continuous exponential growth.
Oh my gosh, there's an example for too.
Yeah, we're going to do this. Okay, continuous exponential growth. At the top of your paper, put this on here. I'll do continuous compound. I'll do compounding. You've seen this equation before. Continuous compounding. A equals P e to the RT power. I call it PERT. All my trig kids call it PERT. We just got into this. P e to the RT power. Do we need to go through and define the variables?
No.
A, P, R, T.
Yesterday.
Yeah, we did PERT yesterday. Yes, right. So A equals P e to the RT power. That's going to be the one that we use on the next example. Okay? This is continuous compounding, but put this at the top of your paper so that you know what equations you can use. Ready? Example. Example 3. All right, example 3. In 2015, the population of the state of Georgia was 10.2 million people. In 2010, it was 9.7 million. All right, so which one happened first? The one they gave us second, right? So that's kind of confusing. I'm going to write that one first. 2010, the population was 9.7 million. And 2015, the population was bigger. It was 10.2 million. Okay? All right. They want us to find the value of K. I guess in this case, they're saying what's the growth rate. So they're having us solve for R in this case. I don't like their variables. I'm renaming things. Sorry. Find the value of the growth rate. So, all right, here we go. In 2010, it was 9.7 million. In 2015, it was 10.2 million, okay? We do not have to, as long as these are in the same units, we do not have to put the zeros after the million on the end of there. So we can just use 9.7 and 2010. All right, here's my formula. A equals P e to the RT power. Okay, they have given me A and P. We just don't know it yet. What is P and what is A?
A is 9.7. Or P is 9.7.
P is 9. We started with 9.7, right? Like that's our first number that they gave us. And we're ending with 10.2. Okay? E to the R. R is what we're solving for. But what is T?
5 years. 5.
Ah, right. The difference between 2010 and 2015 is 5 years. So we're going times 5, right? Good? Happy with that? Ish? Okay. Now we have to solve this. R is up in the top, so we've got to figure out how to get him down. So what do you want to do first? What would you like to do first? We've got to undo this stuff. Not ln yet. Nope. Divide by 9.7. You always divide that first number off, just FYI. If there's a number there, you get rid of it. 10.7 divided by 10.2 divided by 9.7. Tell me what that is. What? Anybody?
1.05.
Okay, we'll go 1.051. Okay. Now, can I make that e to the 5r power? Can I switch that around? Like, instead of r5, we make it 5r. Can I move that and make it 5r?
Can we
Okay.
make it an exponential function?
What? It is an exponential function.
Or a ln function?
An ln function. You want to make it a log? I'm going to ln both sides, which is the same thing as making it a log function. So I'm going to ln, and I'm going to ln. And what happens? Cross off ln and e. So I have ln of 1.051 equals 5r. And then what?
Divide by 5.
Divide by 5. But make sure that when your calculator does it, you close off the parentheses. So r is going to be 0.
0.0.
Ooh, that's not what Ellie got.
Teachers, please dismiss the 8th graders to the high school library. All 8th graders, please go
What?
to the
I
high
thought they
school
were supposed to be
library.
testing already.
1:30.
They said 1 o'clock in the email.
Okay.
You
Okay,
read 1:30.
whatever.
0.0.
That's not what Ellie got. Anybody else do it?
What?
Connor's our tiebreaker, maybe. ln of 1.051 divided by 5. You need to make sure.
Previous answer, but extended decimal places.
Oh.
Instead of 1 point.
What did you get?
Like 1 point. It was like 1.0.
I got 9.9.
I got 0.210.
Well, it's an interest rate, so it's got to be 0 point something.
I guess 0.01.
Got 0.21.
Well, let me solve this here. ln. Let's do ln 1.051 divided by 5. Whoa, I got 0.0099.
Wait, doesn't the LNs cross off?
0.01.
Yeah, 0099. So 0.01.
0.01.
Right. So 0.01, because this guy will round to 0.01. But what does that mean? My growth rate is 1%. I have a 1% growth rate.
That's really low.
I have a 1% growth rate. It's not growing very fast. Okay? Not growing very fast at all. All right. B says, when will Georgia's population reach 12 million people? So what is 12 going to be now?
The end.
The end. That's the after amount. So 12 equals, what are we starting with?
Still 9.7?
Still 9.7. E to the, we know our interest rate is 0.01, so I'm going to put my interest rate in there. But now we don't know T. So T is going to go up there in that top. Okay, and now we're going to solve this just the same as what we did before. What do we do first? Divide 9.7. 1.2371. Okay, equals e to the 0.01 t power. And then what? Then we ln. See, we're getting used to this. Ln and e cancel. So we have ln of 1.2371, whatever that is, equals 0.01 t. And then I divide by 0.01. And the time is something.
2.1278.
Are you sure?
Oh, it's, yes, 2.1277. 7.
I did the.
That's not what
I did too.
Did you use ln or log?
LN.
What did you get?
I did the previous one.
I got 21.27. Did you divide by
I
0.01
Oh,
or
0.1.
0.1?
Connor, grab your pen.
Oh, okay, then it's only one.
Yeah. It's because you divided by 0.1. So I got 21.3.
Oh, 0.01?
You know how I knew you were wrong? It takes 5 years to become 10.2. So it's going to take more than 5 years to become 12.
Now what am I doing?
I don't know what you're doing. Okay, now it's just not doing what it's wanting to do. So ln of 1.23771 divided by 0.01. Okay, 21.3. Okay, but that doesn't tell me when.
21 year.
21.3 years past when?
2010.
2010. So 2010 plus 21.3 years is about the year 2032-ish. That is when the population of Georgia will reach 12 million. Okay? 2032. Yeah? Because 21.3 was our T, and we're starting in year 2010. Right? So if 2010 is like our year 0, then 2020 or 2032 would be year 21-ish. Okay? Good? All right, we're going to skip part C, and we're going to skip this bottom part right here. So let's go to the homework, and I'll tell you which ones to do. I got to read through them, though. We're going to skip number 1 on skills practice. Okay? Number 2, you can do. Their formula that they use is weird. I usually call this A and I call this P. They're just using different variables, and that is fine.
Can you use your variable?
You can use my variables, but they will call like A is the current population in millions, so we call it P, whatever. You could switch them back around to my variables. It doesn't matter, it's just what they have named them. So they might name them something different, but this is the formula you're using. You're using that PERT formula, okay? So do number 2. Do number 3, they give you the formula here, except they call it P, we call it A. So if you want to switch that, you can. So do number 2, do number 3, and you can skip number 4. Okay? So 2 and 3 on that side is what you can do.
And probably 2 and 3 on the back.
Next, let's see what's going on here. I don't want to do number 1. I don't want to do number 1 because they give you weird things. I don't want to do number 1. How long is the population? What will it be in 17 years' time? How many hours? Okay, which one do you like better, 2 or 4? You're gonna do 3, but which one would you like better, 2 or 4?
4.
You like 4 better?
I don't know, it looks shorter.
You think?
No.
They're both kind of equal difficulty.
I'm so confused, I don't even know how to do them anyway.
Do 4?
Yeah.
Okay. Okay, sure. Skip 2. Okay, 3 and 4. So actually, we just should have just done 2. That way we could just say 2 and 3 and 2 and 3. But whatever. 2 and 3 and 3 and 4. There you go.
Okay, tell me
Okay,
how to-
4 problems. That's not bad. I cut it in half. That's okay.
Now you have to tell
Okay.
me what to do.
You fill stuff in. Just start plopping stuff into the spots.
But I have no idea.
You just start plopping stuff into the spots. So get a place to plop, and then you ask me. Bye, Carter, and whoever's watching this 8th period.